Good evening, everyone. In this video, I'll be discussing about inter-process communication. So, inter-process communication, it is actually the backbone for distributed computing. Okay, it is the ability for separate and independent processes to communicate among themselves to actually collaborate on a task. So the idea is like there are different processes. Process one is here and process two is here. Okay, so these processes are actually communicating, and they are separate processes and they are independent processes. Okay, so these independent processes can be existing on the same machine, but they can also be existing on completely separate machines. Okay, that's how we have seen, like, say for example, in distributed computing and distributed systems based applications, we have seen like several applications where like the processes are executing at different places. Say for example, most of the applications which we have seen are based on web based applications. So that means like there are certain processes running on the server, certain processes running on the clients, and certain processes running probably maybe on the intermediate nodes or something. Okay, which are actually called as middlewares. Okay, so that means like these processes are existing, okay, on separate nodes. Okay, and they are completely independent. They are working on their own, but they can actually communicate. The inter-process communication actually facilitates this. Okay, this sort of communication. Okay, so basically, like this sort of communication actually follows a specific protocol. So these two or more processes actually engage in this sort of inter-process communication in a protocol. Okay, this protocol is actually agreed by both the processes. I mean, like whenever like two processes are communicating, okay, so through this inter-process communication, so they agree on a specific protocol. Both of them should agree. So here the protocol is like a set of rules that must be observed by the participants in the data communication. Both the participants should basically agree. Okay. For that particular sort of inter-process communication, sometimes like a node can participate as a sender. Okay. At other points, it may even act as a receiver. So it is not fixed. Like say for example, one of the process should always be sending. Okay, or like receiving. It can act as both the sender and also receiver at certain points. Okay, when they actually follow the protocol. Okay, I will be giving you the examples for this one in the coming slides. But when the communication is actually from one process to the other process, okay, to one another, so a single process, if the communication is happening from one process to the other process, then it is called as unicast. So the inter-process communication is actually said to be unicast. However, when the communication is from one process to a group of processes, okay, then the IPC is actually said to be multicast. Okay, so this is the difference between unicast and then like multicast in terms of inter-process communication is concerned. So this sort of inter-process communication is actually facilitated by operating system itself. Operating systems actually provide some facilities for this sort of inter-process communication. Well-known examples are like these message queues. Okay, say for example, operating systems uh, have the provision for these message queues using which like these sort of processes can communicate. And we can also use semaphores. We have actually seen like while discussing the threads, we needed to achieve mutual exclusion between threads. So these things are actually achieved by semaphores. So you can also achieve inter-process communication through them, and you can also achieve that through shared memory as well. Okay, and when IPC is provided at this level, they are actually called system level IPC. You can develop applications using this system level IPC, but then you are really tweaking very basics of the services provided by the operating system. Most often for building these sort of distributed computing applications, you will not be doing that one. Okay, rather like distributed computing systems make use of these facilities to provide application programming interfaces, APIs. And while you develop your applications, you will be using those APIs. The fundamental idea of these APIs, provisioning of these APIs, is like you are actually giving the programmer different levels of abstraction. This is one of the main features of object-oriented design. Okay, so we have quickly discussed the software engineering basics as well, where we have talked about object-oriented design. Object-oriented design fundamentally pushes the idea of supporting different levels of abstraction. So these API actually allow this inter-process communication to be programmed at higher levels of abstraction, which is actually good. Okay, so the source code becomes easy, and then like the number of errors which the programmer will make will also be reduced. So if conceptually, if we really look at this sort of inter-process communication, okay, and then like if you want to really look at like what are the sorts of methods which are to be provided, okay, in such an API, which actually facilitates this inter-process communication, okay. So that is the archetypal inter-process communication. Primarily, you need to have support for four primitive operations. The first one is the send, okay, which should have the information about the receiver, okay, the receiver process, and the message whatever you are actually sending. So this send operation is actually issued by the sending process. If there is a sender and then like a receiver, the send operation is actually issued by the sending process, okay, for actually transmitting some data to this sort of receiving process, okay. So then the operation, whatever you are putting there, that send operation must allow this sending process, okay, to identify the receiving process. It should be able to identify the receiving process. Then only it will be able to transmit the data to this sort of receiving process. So that's about the send operation. This is fundamentally issued by this sort of sending process. The second operation is receive operation. So the exactly the other way around. Okay. So the receive process actually need to know the sender who is actually sending the message, and also like this sort of message storage object. So this receive operation is actually issued by this sort of receiving process. The sender process, sending process, and the receiving process. The receiving process is the one which actually issues that receive. Okay, receive operation. And primarily it is issued to basically accept the data which is actually sent by the sender. Okay, so the receiver the receive operation actually must allow identifying this sort of sending process in that case. At the same time, like it should also specify the memory space, okay, that actually allows the data to be stored, okay. So the data is to be stored somewhere, okay, and this receive method will also tell this sort of receiving process where that data is stored, so that subsequently this receiving process can actually access that data, okay. All that information is actually specified in that particular receive operation. So the other important methods are this sort of connect, okay. Connect is a method. For that one, like you need to have a sender address and also a receiver address. This is primarily used for establishing connection oriented communication. So you will be establishing a connection first, and then like you will be actually achieving this sort of inter-process communication, okay. So this connect method actually allows a logical connection to be established between the issuing process and a specified process. So basically, like if the sender is actually sending an operation, okay, so basically it is issuing an operation to basically establish a connection, okay. The logical connection is actually established between this sending process, and you will be specifying a different process to which like you actually want to connect, okay. In this complete communication, okay, so between this one, okay, for establishing this connection, one process actually issues the connect operation, and the other process actually issues an accept connection operation, okay. So the sender is actually establishing a, for example, like the sender is establishing a connection, okay. It basically actually has to establish a connect, okay, and then like the receiving operation, I mean like the receiving process should actually issue an accept connection operation, okay. I'll be showing you an example, okay, with HTTP protocol. Once you have established this connection, the disconnect operation, okay, so using with this one, like you can actually release whatever like the established logical connection, okay, and you can actually deallocate that connection which is actually established between these two processes, okay. One more thing which we should really remember is like the issuance of an operation causes the occurrence of an event. Okay, this is also very critical in terms of inter-process communication. Say for example, when you are actually issuing a sending operation, okay, sending operation by the sender, for example, okay, this actually results in an event. The event is actually the data is actually transmitted. Similarly, like when the receive operation is actually issued by the sort of receiver process, okay, an event will be generated. Okay, an event in this particular case is like the data is actually received and then like it is stored in an object. Okay, and that's what we have been discussing here. Okay, so the data is actually stored somewhere, and that is the event. The data is actually stored there so that like the process receiving process can eventually read it. So in that sense, like the issuance of an operation actually causes an event to occur. Okay, so let's try to look at in terms of an example for inter-process communication. Say for example, let us look in terms of the basic HTTP. So this is about a web server. Okay, so that means like you have all the web servers. So I already have discussed about this sort of communication when I was even talking about the servers. Okay, so there is a web server. So literally this is what you are using over the internet. From your browser, you are actually trying to access any web page. That means like you are trying to connect to that particular server. Okay, so in theory, we have actually discussed earlier that there is a process running in the browser and then like there is a process. Say, for example, in that example earlier, which I have given, is a servlet process which is running on the web server. And these two things are actually communicating. But in terms of inter-process communication, this is all what is actually happening. So the web browser, okay, you have a process, and the web server, it also has a process. It can have several processes. For example, like think like it has only a single process. Okay, for this sort of for the sake of this discussion about inter-process communication. Now, when you start the browser, you are, say for example, you are trying to enter a URL, you are actually trying to make a connection with that particular web server. So that means like this web server, web browser actually issued this connect operation. In response to that one, S1 actually has issued accept connection. Then only this sort of connection is actually established. Then basically like the web browser will basically send, okay, so it will send a request. Okay, so the request is in this case like it is trying to send the information like a URL or something. Okay, so it is the request it is trying to send. Okay, and then like from the web server perspective, it is actually receiving the request. See this one, the actual inter-process communication has to go through all these sort of operations. Okay, so when you are sending the request, okay, you are, I mean like the server is actually issuing the receive request operation. Okay, then basically like uh, okay, so the request is actually received, the web server basically processed. Okay, and then like now it has the response. Okay, so for example, whatever the web page which you have requested, the actual contents, these are to be sent to the browser. So then like the web server actually initiates the send response. Okay, issues this sort of send response operation. In response to that one, the client basically says like, I mean, issues this receive response operation. Okay, and then like the server is the one which actually disconnects. Okay, so it is S4. Okay, and then like basically like the web browser also issues this sort of disconnect operation. Then only the connection is actually completely disconnected. Okay, so this is how like inter-process communication is actually happening. Okay, even for the simplest case like which we have actually been seeing, you know, a web browser trying to connect to a web server which you are using over the internet always. So that's about the inter-process communication. Okay, very quick introduction about it, and we'll be discussing about all its aspects in the coming videos. Okay, coming 4 or 5 videos. So regarding the reference is concerned, now we started with chapter 2 of this distributed computing principles and application by ML Live. Thank you very much for your attention.